Hey guys, Miss Viren here. Welcome to Unit 5, Notes 5. We're going to go ahead and look at quadratic applications. So, we're going to put together everything that we've kind of talked about and go ahead and solve some word problems here. There's two different types of word problems that we're going to look at. We're going to look at word problems that ask for the maximum or the minimum. When I ask you to find the maximum or the minimum, remember that's just another word for the vertex. So I'm actually asking you to find the vertex. So if you think back to Unit 5, Lesson 1, when we were kind of looking at finding the vertex, we used the formula x equals opposite of b divided by 2 times a. And then we plugged it back in to find the y. So anytime I'm looking for a word problem that says find the maximum or find the minimum or find the greatest height or the least cost, that's a high point or a low point. So remember, that's just finding the vertex. I can also give you word problems that ask you to find it when it hits the ground or when it hits the highest point. That is going to be asking you to find out what your x-intercepts are. And this is kind of what we looked at in the previous lesson when you had 3 different options to solve. We could factor and then use ZPP, zero product property. And remember, that's the x method and then setting the factors equal to 0 and solving. Or we could use quadratic formula. Almost always for word problems, you want to go ahead and you want to try the quadratic formula because I'm usually going to give you decimals or numbers that don't come out so nice or they're really big. So when I'm asking you to find when things hit the ground, you almost always want to use your quadratic formula. So here's our first example. The height h of an object t seconds after it is propelled upward with an initial velocity v is represented by h equals negative 1/2 gt squared plus vt plus h, where g is the gravitational pull and h is the initial height. So suppose an astronaut on the moon throws a baseball upward from 2 meters above the ground with an initial velocity of 10 meters per second. Suppose the gravitational pull on the moon is a constant of 1.6. Determine how many seconds it will take the baseball to return to the ground. So we're going to go ahead and we're going to plug in what we know to that equation. So I know that h equals negative 1/2. My g, remember g is the gravitational pull. It tells me that the gravitational pull on the moon is 1.6. So I know that g is 1.6 t squared. Plus v is my initial velocity. That tells me that it's 10. And then h is my initial height. So I threw this from 2 meters above the ground. So I'm going to go ahead and I'm going to do 1/2 times 1.6. So I'm going to get negative 1, I'm sorry, not negative 1/2, we're timesing that. We're going to get negative 0.8 t squared plus 10t plus 2. And the question is asking, when is the baseball going to return to the ground? So I know my height is 0. That also tells me that I'm going to have to use the quadratic formula to solve this. So I'm going to use t equals opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So I'm not going to go through the steps to solving this, but remember, in your calculator, you're going to go ahead and you're going to put everything underneath the radical in first. So we want to go ahead and make sure that we put this stuff underneath here first. And then I'm going to take the square root of it and then get my 2 separate equations. When you do all of that, you should get t is going to equal negative 0.2, and then t is going to equal 12.7. Now remember, we're asking how many seconds it will take. It doesn't make sense to have negative seconds, so my answer is going to be 12.7 seconds. So looking at the second part of this problem, it says suppose someone threw the ball from the same height and same velocity on Earth where the gravitational pull is a constant of 9.8. When will the baseball hit the ground? So we're going to have the same equation except we're going to change our gravitational pull. So I'm going to have negative 1/2 times, it's going to be 9.8 now. But I'm still going to have plus 10t plus 2 because my initial velocity and my initial height stay the same. So when I simplify this, I get negative 4.9 t squared plus 10t plus 2. And again, since it's talking about when it hits the ground, we're going to go ahead and we're going to use the quadratic formula. So I'm going to get t equals opposite of b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. So you go ahead again and go through those steps to solve that quadratic. And I would get t equals negative 0.18 and t equals 2.22. Yet we want the positive, so I know that it takes 2.22 seconds if I was on Earth. So make sure that you're really plugging those into your calculator and trying to see if you get the same answer that I get. So now example number 2, Jimmy John's is tracking its sales of subs. The manager sees that the quadratic representing this is y equals negative 25x squared plus 250x plus 400, where x is the number of subs sold and y is the revenue earned. What is the maximum revenue earned and how many subs were sold to earn this revenue? So if I'm looking for the maximum, this tells me I'm looking for the vertex. So I'm going to go ahead and I'm going to use the formula x equals opposite of b divided by 2 times a. So the opposite of b divided by 2 times your a value. We always do the multiplying first before we do the timesing. So when I plug this in, I know that x is 5. So now I'm going to take that 5 and then I'm going to plug it back in to solve for y. So instead of x, I'm writing 5. And again, instead of x, we're going to write 5. And we can plug this exactly into our calculator the way we see it. Make sure you put your parentheses around the number you plugged in, and it should come out really nice for you. If you broke this down, I would do 5 squared first, and then I would times that by the negative 25, and I would get a negative 625. 250 times 5 gives me 1,250 plus 400. So I would get 1025. So we want to think, the question's asking what's the maximum revenue earned and how many subs were sold to earn this revenue. When you're looking at this logically, it makes sense that the 1025 would be my money and the 5 would be my subs. So after 5 subs, so it's going to be 5 subs, I'll have $1,025. So example number 3, a projectile is shot vertically up in the air from ground level. Its distance y in feet after t seconds is given by y equals 96t minus 16t squared. Find the values of t when y is at 96 feet. So this right here, find the values of t when y is at 96 feet, tells me I'm going to go ahead and I am trying to use my quadratic formula, or I'm trying to find my x-intercepts. So we could try factoring it if we wanted to as well. So it is telling me that y is going to be 96. So I'm going to plug that into the equation for the y value before we can go ahead and try to solve this thing. We also know now that we have to be set equal to 0. So in order to be set equal to 0, we're going to subtract the 96 from both sides. And I'm going to go ahead and I'm going to rewrite this side so that it's in standard form. So I have my ax squared plus my bx plus my c. Now we're just going to go through our steps of trying to solve this. So is there a GCF? In this situation there is. I can take a 16 out. And because my a is negative, I always want that a to be positive, so I'm going to take a negative 16 out. So I'm going to get 0 equals t squared minus 6t plus 6. Now I know I'm trying to solve this, so I solve by factoring or by quadratic formula. I'm going to try factoring and see if it works because the numbers are pretty small. So I'm trying to multiply to 6 and add to a negative 6. In this situation, that didn't work out in my case. There are no factors that do that. So if that doesn't work, then I can do quadratic formula. So I'm going to do t equals opposite of b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. When you are plugging this into your calculator, make sure that negative 6 is in parentheses. Otherwise, it's going to screw your answer up. So I ended up getting 6 plus or minus the square root of 12 divided by 2. So I got 6 plus 3.46 divided by 2, and 6 minus 3.46 divided by 2. So I ended up getting an answer of 4.73 seconds and 1.26 or 27 seconds. Both of these are positive, so both of these would be okay answers. So our last example here, it's actually example number 4 for us. So on one of the banks of the Chicago River, there is a water cannon called the water arc that sprays recirculated water across the river. The path of the water arc is given by the quadratic model y equals negative 0.006x squared plus 1.2x plus 10, where x is the distance across the river and y is the height of the arc. What is the maximum height and how far across the river does it travel to reach that height? So I want you to go ahead and try this problem on your own. Pause the video, come back and check your answer when you're completed. So when I read this, the word that stuck out to me was maximum. Remember, maximum tells me I need to find the vertex. So I'm going to use the formula x equals the opposite of b divided by 2 times a. So when I did that, I ended up getting 100 for my x value. So once you find your x value, you have to plug it in to find your y value. Your answer then, to determine what is what, because 10 or 170 doesn't really help us out, we need to look back up here. We know the x value, that x value is the distance across the river, and the y value is the height of the arc. Okay, so I know that the y value, what I found down here, is my height. So I know that the max height is going to be 70 feet, and that's going to happen at 10 feet across the river. So your next step is to work on your practice problem for 5.5. If you have any questions, please come talk to me before moving forward.